Okay, so hopefully you got through graphing this 1 over x function okay. And now we're just going to look at some of these properties. What's it look like from here? So first off, we want to think what's similar, what's different of this graph to any others. And I would think the big thing you might notice is different is we have asymptotes. We have lines that this graph never crosses. And we should say there's imaginary lines or invisible lines maybe that the graph never crosses. And those lines, you may have heard this back when you guys did exponentials a couple years ago, are called asymptotes. So they are lines that the graph never crosses. So you'll see there's a vertical one right here, and that is at the line x equals 0. And then there's also a horizontal asymptote at the line y equals 0. And these will be a part of all of these rational graphs. This, whenever there's a variable in the denominator, these lines will exist. So the end behavior for these, remember end behavior talks about when we move to the right, when we look to the right, and when we look to the left. Whoops, negative infinity. Make sure I write that correctly for you guys as we go to negative infinity. So remember, when we say this as x approaches infinity, that means as we look to the right of the graph, what is happening? Well, if we look to the right of this graph, so we're going in this direction, the graph itself, notice it's getting closer and closer to that axis. It never touches the axis, but it's getting closer and closer. For this, as x approaches infinity, f of x is getting closer and closer to 0. So as we look off forever to the right, y is getting closer and closer to that 0. Okay, so now let's look. When we say as x approaches negative infinity, that means we look to the left. So this time we're looking this way. This is our left. And again, as we are going further and further to the left, we may be coming from the bottom, from the negative side, but the graph is still getting closer and closer to 0. And if you think about the y of that, on this why it says, think about it in terms of the table and the graph. As we get further out, those fractions are getting smaller and smaller and smaller. So like when we plug in, say when x equals 100, well that means when we plug that in, f of x is its reciprocal, 1 over 100. Tiny fraction. If x were to equal 500, so we're getting further and further out, f of x is 1 over 500. So the bigger our input gets, the smaller the output gets. And that's why it approaches 0, because it's getting to be a smaller and smaller fraction. These last two talk about describing it, this time instead of as we go out to infinity, as we get closer to 0. So notice it says describe g of x as x approaches 0 from the left. So here's our left side. So as we get closer and closer to 0, what's the graph doing? Well, let me get another color here. As we get closer and closer to 0, this graph is going down forever. So from the left side, g of x is approaching negative infinity. Approaching negative infinity. The numbers are getting a lot bigger really quick. So, for example, if I were to plug 1/2 into this function, or we're going left, the output would be -2 because we're flipping. If I plug -1 over 100 in, really small number, really close to 0, that turns into -100. So as x gets closer and closer to 0, the outputs are getting increasingly more negative, hence the negative infinity. Describe g of x as we go from the right. So the right is over here. So as we get closer and closer to 0 from the right side, notice what the graph is doing is it's getting bigger and bigger and bigger. So from the right side, the graph would be approaching infinity. So all these questions are just getting you to think about what are these asymptotes doing. So what is the graph doing as they approach these special lines that they'll never cross, because they're always getting closer and closer to them. So the next couple slides are going to take these ideas and talk about how that translates into the domain and range of these functions.